Today we are going to learn about mastering Docker for environment configuration. We will explore how to set up and manage Docker containers, ensuring your applications run consistently across different environments.
Docker is a platform that enables developers to build, deploy, and run applications in containers. Containers encapsulate an application and its dependencies in a single package, ensuring consistent environments across various stages of development and production. Unlike traditional virtual machines, Docker containers share the host system's OS kernel, making them lightweight and fast. This means you can run more containers on the same hardware than virtual machines. Key components of Docker include the Docker engine, images, containers, and Docker Hub. By the end of this video, you'll understand how Docker can streamline your development workflow, ensuring applications behave the same in production as they do locally. To utilize Docker, you first need to install it on your machine. Docker supports various operating systems, including Windows, Mac OS, and Linux. For Windows and Mac OS, Docker Desktop is the go-to application that bundles everything needed to run Docker. On Linux, Docker can be installed using native package managers like apt or yum. After downloading and installing Docker Desktop with the appropriate packages, you can verify the installation by running Docker version in your terminal. Once installed, familiarize yourself with basic Docker commands like docker run, docker ps, and docker stop. These will serve as your initial toolkit for managing Docker containers.
A Dockerfile is a text document that contains all the commands to assemble an image. Think of it as a blueprint for your Docker image. Each instruction in a Dockerfile creates a layer in the image, contributing to its final state. Here's a simple example for a Node.js application. Start with from node:14, which sets the base image. Next, workdir/app changes the working directory inside the container, followed by copy/app to copy your application files. Run npm install installs dependencies, and cmd, node, app.js, specifies the command to run your app. After creating a Dockerfile, build your image using docker build t-my-node-app. This will create an image tagged my-node-app, ready to be turned into a container. Once you've created a Dockerfile, the next step is to build the image and run a container. Use docker build t, image name, to build an image. This command reads the Dockerfile in the current directory and constructs the image. After building, run a container using docker run, image name. You can interact with your container using docker execute, containerid, bash, which opens a shell inside the container. To stop a running container, use docker stop, containerid, and remove it with docker rm, containerid. Understanding the container lifecycle is crucial for effective Docker management, as it allows you to maintain clean and efficient environments. Docker provides several commands to manage images and containers efficiently. Use Docker images to list all images on your machine and docker ps to view running containers. To remove unused images, utilize docker rmi, imageid. For sharing, you can tag and push images to Docker Hub using docker tag, image name, username, repo, and docker push, username, repo. Clean up dangling images with docker image prune. Additionally, Docker manages data persistence through volumes and networks, which can be listed using docker volume ls and docker network ls, respectively. Understanding these management commands is essential for maintaining a tidy Docker environment. Docker Compose is a tool for defining and running multi-container Docker applications. With a simple YAML file, you can configure your application's services, networks, and volumes. The Docker Compose.yml file defines each service, for example, a service for a web app and another for a database. Use Docker Compose up to start all services with a single command. Docker Compose handles dependencies, ensuring services start in the correct order. You can also scale services using Docker Compose upscale, service equals new. This makes Docker Compose an invaluable tool for managing complex applications with multiple components. Security is paramount when working with Docker. Start by minimizing your image size. Fewer components mean fewer vulnerabilities. Avoid running containers as the root user. Instead, create a non-root user in your Dockerfile with username. Regularly update your base images to include the latest security patches. Docker provides built-in security features like user namespaces and seccomp profiles, which can be configured for additional security. Additionally, scan your images for vulnerabilities using tools like Claire or Trivy. Adhering to these best practices can significantly enhance the security of your Docker containers. Encountering issues with Docker is not uncommon, but effective troubleshooting can minimize downtime. If a container crashes, use Docker logs, containerid, to view logs and identify errors. Networking issues can often be resolved by inspecting network configurations with Docker Network Inspect. If the Docker daemon is unresponsive, restart it with system to restart Docker on Linux. Docker's documentation and community forums are invaluable resources for troubleshooting. Additionally, consider Docker support channels for more complex issues. By systematically diagnosing problems, you can maintain a robust and reliable Docker environment. Congratulations on completing this overview of Docker for environment configuration. We've covered everything from the basics of Docker, setting up and managing containers, to best practices for security and troubleshooting. Docker is a powerful tool that is essential for modern development, ensuring consistency across environments. As you continue your Docker journey, practice is key. Engage with the Docker community, explore additional resources, and keep experimenting with new features. With dedication, you'll soon master Docker, enhancing your development workflow and ensuring your applications run seamlessly from development to production.